Hi, today we will see sheet metal in Creo. These are all the contents: standard sheet thickness, extruded wall, planar wall, how to create the developed length, and K factor and Y factor. I am creating one wall, new part. Here we have to select the sheet metal, give the name. We are not using the default units, so unselect this. Okay, Newton second, part sheet metal we have to select. Okay, first I am creating one sketch view. by 100. Okay, now I created one sketch. Now we are going to create extruded wall. Extrude, placement, define, sketching plane, sketch, then usage loop, this one. Okay, now we have drawn the sketch. Okay, see, from the sketch either inside wall or outside wall. I have created the inside wall. This is the wall thickness. This sheet thickness I am going for 2. Then this one is 100 mm both sides. All other options are same. I am giving okay. Now here we have given the sheet thickness as 2. Before that we have to know the standard sheet thicknesses. There are two standards are available. One is the imperial system, that is inch sizes, and another one is the metric system, sheets. See, this is one of the table copied from the net. This is for imperial system of units. Gauge sizes 3, 4, 5. See, corresponding thickness we have. So, this is for steel. This is galvanized iron, stainless steel, aluminum. For different material we have different thickness, even the gauge is same. For example, take 28 gauge, the steel having 0.38 mm thickness, galvanized iron having 0.47 mm, stainless steel having 0.41 mm thickness, aluminum having 0.32, little variation. So these things we have to know. Similarly, metric sheets also available, 1 mm, 2 mm, those things also available. For example, we are going to use imperial system of a unit. Otherwise, only these standard sheets are available in the market. Means we have to select the sheet size from this only. For example, we have given 2 mm as the sheet thickness in Creo. So here either 1.9 or 2.28 is available. We have to use any one of these thickness. But in metric we have 2 mm sheet. I am changing 1.9. 1.9 we have to use if we go with the inch sheets. Okay, this is the standard sheet thicknesses. This is extruded wall. In the solid we created full solid. In the sheet metal, see, this one is okay. If we go to hidden line, the one line, one surface shows green color. Just a moment, prepare. See, in the hidden mode, the outer surfaces, see, green color, the inner one is the black. The green surfaces is called driving surface in sheet metal. The another surface is called offset surface. Okay. Shading. Now we know how to create extruded wall. We can use all the options: revolve, sweep, blend. All the way we can create the sheet metal. Now one more planar. This is not available in solid modeling. We will see that one. So I am deleting this. Okay. See, for extrude we have to select and create extrude. It will be like that. For flat, select this, just a planar. Only here we have to give the wall thickness 1.9 mm, either that side or this side. Do okay. In this way we have to create sheets. Standard sheet thickness we have seen, extruded wall and planar wall. Fourth one is the developed length. I am deleting this. I am creating one extruded wall. Okay. Just I am removing one edge. I am removing one edge. I removed one edge. Okay. Now I am going to create extrude. Okay. Extrude. 100 mm. Both side. Wall thickness 1.9 mm. Or we will go with the 5 mm. In the sheet, this is called inner radius. The outer one is called outer radius. Here we can control this. By default, always sheet thickness is considered as a inner radius. The radius. See, thickness we can give. Inside or outside we have to select. We can change this also, but we can use default. Here inside outside we can control. The inside within bracket is the default Creo unit. Thickness. If you want 2 times thickness also we can give. If this one is the Creo default. Okay. Now fourth one is the developed length. How to create the developed length? See, here one flat pattern is there. Just pick this one. References. Fixed geometry, which is to be fixed. I am removed this. Either we are going to fix this one or this one. See, I am picking the bottom one as a fixed one. See, we are getting the sheet like that. Or if I fix this one, see, we are getting the which one we are selecting, that is fixed, the remaining things unfolded. I am picking the bottom one. Okay. This is the developed length. Bend allowance, K factor and Y factor. Whenever we are bending the sheets gets permanent deformation. So the length of the sheets gets increased. For example, 100 mm length. We are selecting 100 mm length sheet, means we are folding 1 or 2 times. If we measure, the final length is more. That is called allowance, sheet allowance. How to control these things? Before that, we have to know K factor and Y factor. In the net, I will show what is K factor and Y factor. This is the K factor. In the comments, I will include these two links. You can refer these things. K factor means, see, we are bending a sheet like this in the corner position. This is the inner radius. R is the inner radius. The outer one is the outer radius. This is the sheet thickness. The inner radius portions material getting compressed. The outer one getting elongation. In between, we are getting one neutral line. In the neutral line, on the neutral line only, we have to measure the length for developed length. Not inner one, not outer one, the neutral line, where we have to measure the developed length. See, this is the total thickness. This is the position of the neutral line, del, from the inner radius. The ratio of, see, the K factor, del by T. This by total thickness gives the K factor. If we need the, what is Y factor means, K factor multiplied by 90 degree or pi by 2 value. Pi by 2 is the 90 degree in radians. Okay. Now we know what is K factor and what is Y factor. This K factor depends upon the K factor only. The developed length are derived. See how to include these values in sheet metal. In the Creo we will see. This is Y factor. Okay. Now this one. See, 200 length, 100 height. See, these K factor and Y factors are depends upon the material. K factor will vary with respect to material. Steel having one value, aluminum having one value. Based on the material, the K factor will change. Also, based on the thickness also, it will vary. For example, in steel, 2 mm sheet having one K factor and 5 mm sheet having another K factor. Also, it depends upon the manufacturing process. The cold rolled, hot rolled, and the surface finish of the sheet. These things also plays the bend allowance. So we can't able to predict this exactly. We cannot give proper value to this. From the experimental results, from the experimental results, we have to take these values and give us a input in Creo. See, we will see how to give these values in Creo. First, in the material, we will see file, prepare, model properties, material, change. I am assigning one material, stainless steel. See, if you double click this stainless steel, in the miscellaneous, see, we have the Y factor is 0.5 value. Y factor is 0.5. Okay. Now we assigned one value by using the material property 0.5. Okay. See, now here see the bend allowance. Bend allowance is 0.5, it taken from the material property. Okay, now I closed this. Now measure the length. Analysis, measure distance. Hmm. 380.708. For y factor 0.5, 380.708 mm. Okay. Now I am changing this value now. File, prepare, change. Instead of 0.5, I am going with 0.2. Okay. File, prepare. See, I regenerated. See, the y factor is 0.2. Now we will see the length. Measure length. I think no, it won't take. From here to 377.788. 0.2, 377.788 mm. See, we are getting for y 0.5 we are getting 380, for 0.2 we are getting 377 only. Similarly, if we change some other value, we will get different developed length. Okay. Here we by giving the material property, by giving the y factor in material property, we can get the developed length. But the y factor, now y factor can vary with the thickness also. 2 mm sheet, 5 mm sheet. If we assigned in the material, it won't play in thickness. So here also we can change in one more place. File, prepare, model properties. Here also we can change. See, y factor. If we regenerate, we will get Control G. File, prepare, model properties. Okay, this is taken from material property. See, without change. Here, see, bend allowance, we have to pick the change. See, k factor, y factor values we can give. See, the tick we have to assign from material. Remove this one, give the value, we can. Okay, we are getting in the material, this is 0.5, but we have changed it to 0.3. This is also not work based on the thickness. So this is also similar to material only. This is common for all features we are creating, 2 mm or 5 mm, whatever. So here also we can change. So I am telling this. In one more place we can change. Go to extrude wall, edit definition. See, here one more bend allowance is there. Pick. This is taken from material. See, for this feature, if we went the, see, pick this one, give the y factor 0.5. K factor always for steel, I think 0.33 nearer. Y factor is 0.5. So by giving the value here, we can get the better results. See, now 0.5, the same value we will get. 380, the first one we are getting. So controlling here is better. Controlling here is better compared to earlier methods by assigning material or by assigning in setup. Okay. See, some y factor experimental results values are there. See, these are all experimental results. See, by manufacturing process also it is varying. For air bending, for bottom bending, like that, coining. See, up to 3 meter thickness, not meter, I think, radius, sorry, 0 to 3 meter. See, 0.52 is, this is the y factor value, 0.52 for steel, sorry, for aluminum, for steel 0.6, for stainless steel 0.63. This is the experimental results. These values also we can use. For example, now we have gone with the stainless steel. So for this radius or this thickness 0.63, we can assign this value here. This is the y factor. We have to carefully assign this value. See, either k factor or y factor. Here given is the y factor. See, y factor 0.63. Okay, good. Now this is the proper developed length. .382.008. Point 382.008. The y factor value is 0.63. Okay. So this k factor and y factor plays a major role on developed length. Based on the developed length only, manufacturer cuts the sheet size and create the component. So we have to know these details well to give the developed length to avoid the errors. Then okay, these things we have completed. In the next class we will see how to create some other features like a flat, flange, bend, rip. These things in the next class we will see. This is just introduction to sheet metal. Thank you.